See, Standard 10th Max, Chapter 6, Trigonometry, Exercise 6.3, First sum. From the top of a rock, 50√3 meter high, the angle of depression of a car on the ground is observed to be 30 degree. Find the distance of the car from the rock. See, let me take the rock as a line here, AB. Its height is given as 50√3 high, 50√3 meter. So the car is somewhere, some distance from this rock. Let me take that position as C. See, from the top of a rock, the person is standing at the top of the rock. So his normal sight is this. He is looking at the car C, that is the angle of depression. He has to bend his head. So angle of depression, that is equal to 30. When the person is at the top means you have to draw the normal sight. That is the line parallel to the ground. So his angle of depression is 30 degree. So this always you have to bring the angle of depression to this, the alternate angle. See, alternate angle, the normal side and the ground is parallel line. So you bring this 30 here to the ground, 30 degree. Find the distance of the car from the rock. So you have to find this as X. So we have the triangle ABC. So AB is the rock and its distance is given as 50√3 meter. And C is the car, position of the car. So you have to find what is BC, the distance of the car from the rock, and also the angle C. Here in triangle ABC, angle C, this is 30 degree. You write the remaining letters here A and here B. So I have to find X. What is X? So apply tan. So tan 30 is equal to opposite side. Opposite side is AB by BC, adjacent side. Opposite by adjacent. Tan 30 is 1/√3. AB is given height of the rock, 50√3 by X. So cross multiply. 1 into X is X. 50√3 into √3. So 50 into 3. 150 meter. 150 meter. So the distance of the car from the rock. The distance of the car from the rock is equal to 150 meter. Let me do the second sum. See the next question. The horizontal distance between the two buildings is 70 meter. See, two buildings, the distance between them is 70 meter. The angle of depression of the top of the first building when seen from the top of the second building is 45 degree. If the height of the second building is 120 meter, find the height of the first building. See, two buildings are here. One is taller and the other one is the smaller one, AB. Let me mark this taller building as AB, whose height is given as 120 meter. The other one is smaller than this, its height. Let me take the CD as the second one. Let me mark this as the first one. Actually, first building CD, second building AB. The distance between these two buildings, the horizontal distance is given as 70 meter. 70 meter. So the person is standing at the top of the second building. Normal sight is this. He is looking at the top of the first building. First building, whose angle of depression is 45 degree from the normal side to the side or normal side to the side of this person. He is looking at the top of the first building. So let me draw the parallel line to the ground here. Let me mark this as E. E. So here 45 means these two are parallel lines. So here also I will get all angle of depression, always you have to bring it down. So this is 45. So this is 70 and this is also 70. Question, find the height of the first building H. So AB, taller building. The height is given as 120 meter. And CD, shorter one. CD I have to find. So I take here the triangle. So here only you will get 45 degrees, smaller one. Triangle A C E. ACE. Angle C is 45 degree. C is 45 means write the other two letters A and E. So take tan 45. Tan 45 is equal to opposite side AE by adjacent side CE. Tan 45 is 1. See, what about AE? AE we don't know, but this is fully 120. This is H. So up to this H you have. So this distance will become 120 minus H. This distance become 120 minus H. That is AE, 120 minus H. And CE is 70. Cross multiply 1 into 70, 70, 120 minus H. Take this H to the left side, minus H comes to the left side, it becomes plus 120 there itself. Take this 70 to the other side, minus 70. So 120 minus 70 is 50. So H is equal to 50 meter. So the height of the first building. I have taken that as the shorter one, height of the first building. First building is equal to 50 meter. 50. See, third sum. From the top of the tower, 60 meter high, the angle of depression of the top and bottom of a vertical lamp post are observed to be 38 degree and 60 degree respectively. Find the height of the lamp post. See, the tower we have AB. The lamp post is some distance from this tower. Let me mark it as CD. So this is the horizontal distance. From the top of the tower, 60 meter high. The height of the tower is 60 meter. So his normal site is here. He is looking both the top of the lamp post and also the bottom of the lamp post. So the top of the lamp post, the angle of depression is 38 degree. Here this is 38 degree. The bottom of the lamp post is 60 degree. Here the bottom 60 degree. So you draw the line parallel to this BD. Let me mark this as E. So here 38 degree means the same line touches here. Here also you will get 38. And this 60 touches the line AD. So here alternate angles are equal. 60 degree. These lines are parallel, so alternate angles are equal. So first let me write what are given. AB, tower, So AB is equal to, they given 60 meter. CD lamppost. So you are supposed to find the height of the lamppost. Let me take this as H. Okay. And here we see the two triangles, right angle triangle. See, one 90 degrees at E, the other 90 degrees at B. See, take the bigger triangle first. Triangle ABD. ABD. So here angle D is here 60. Angle D is 60. So write the remaining letters ADB. And take the smaller triangle AEC. Triangle AEC. AEC. So here angle C is 38 degree they given. So write the remaining letters A, C, E here. So take tan for both the triangle. Tan 60 I am taking here. For this, -38 tan 38. So look at that. So tan 60, opposite side by adjacent. AB by BD. Tan 38, AE by EC. AE by EC. Say, let me mark this BD as X. Both are same distance. BD and EC are X. So let me mark that X. So tan 60 is √3 and height of the tower AB is 60 and let me take this as X. Tan 38 degree, the value is given for you 0.7813 is equal to AE we don't know. So let that distance, let me mark it as, so this one you have taken as X. So you keep this as it is AE, EC as X. Okay. So both the terms have the X term. So equate them. So we take this X to this side. So 60 by √3. Bring this √3 here. Then X here. AE by 0.7813. 0.7813. So both the equations are equal. 1 and 2 are equal. So these two equations are equal. So let me take this one. Both are equal text. So 60 by √3 is equal to AE by 0.7813. So just take this 60 into 0.7813. You take to the denominator, numerator by √3. This is your AE. So that's all. You have to find AE. Find the value of AE. See, denominator you have the irrational number. You rationalize it by √3. So √3 by √3 is equal to AE. So √3 by √3 is 3. 3. That 3 goes here into 60. See, let me write that. And also √3 value is 1.732 by 3. This is equal to your AE. This 3 goes here 20 times. 20 times. So you multiply these three numbers. First you multiply 20 and 1.732. So you will get here 0, 2 2s are 4, 2 3s are 6, 2 7s are 14, carry over 1 3. So 34 point into 0.7813. So you multiply these two numbers, you will get here 27.064. So You correct to 2 decimal places, 27.06, because the third one is less than 5. Okay, so this is your AE, that is some distance of this tower, but full distance of tower is 60 meter. So you need to find here this distance H. Actually this CD is same as BE. Let me take this H. So in order to find this BE, AE plus BE is equal to 60. So AE plus BE is equal to 60. So I got AE as 27.06 plus BE is equal to 60. So BE is equal to 60 minus 27.06. So you subtract 60.00, 27.06. So 4 here, 9, then 9 here, 3. Sorry, from 9, 7 goes means 2, then here 3, 32.94. So this BE is same as our CD. CD is 32.94 meter. What is CD? Height of the lamp post. Height of the lamp post is equal to 32.94 meter. Thank you.